Hi everyone, I want to welcome you to another section, and in this video I'll be moving forward on some of the things we have discussed on UV ultraviolet visible light spectroscopy. In this particular video, what we want to talk about is just about terms that are used some of the times that are important for us to know in UV spectroscopy. I'm going to be highlighting these terms and I'm going to be giving us explanations and things that we have to know about them, which will help us in subsequent things that we're going to learn under UV spectroscopy. First, the first term we are going to be looking at in UV spectroscopy, which we have to know, is chromophore. Chromophore are part of the molecule that are responsible for its UV absorption at the same time for its coloration. So in most of the molecules we are going to be looking at, there's always a part of the molecule that is responsible for the UV absorption. That part of the molecule is what we call the chromophore. So, and for UV absorption, the chromophore is usually an unsaturated part of the molecule, because we have said earlier that conjugation is very important for UV absorption to take place. And conjugation is when you have two double bonds being separated by a single bond. So it implies that chromophore that we're going to be looking at for molecules that can absorb UV will be part of the molecule that contains a conjugated system. So this is the part of molecule responsible for its UV absorption and its coloration. Usually unsaturated. Now, the next term we are going to be looking at is the oxochrome. Oxochrome are also part of the molecule which enhance absorption of UV of light in the UV region. They are not entities that really absorb the UV light, but they always enhance UV absorption. So, like I said, this is the part of the molecule. This part of the molecule that enhance absorption in the UV visible region. And usually, oxochromes are usually directly attached to the chromophore. So, and I've said that they don't in particular absorb UV light, but rather they enhance the absorption of light by the chromophore. The next term we are going to be looking at is what we call bathochromic shift and isochromic shift. Now, these two terms have to do with wavelength, because we have said there are two particular quantities that characterize absorption in the UV region, which is the wavelength of absorption and also the intensity of absorption. So what is bathochromic shift? Bathochromic shift occurs when there is an increase in wavelength of absorption. So if the wavelength of absorption increases, then you say that you have a bathochromic shift. And another term for bathochromic shift is also the red shift. So like I said, this is when there is increase in wavelength of absorption. So when there is increase in the wavelength of absorption, which can be caused due to several reasons, then you said that you have a bathochromic shift. And note that an increase in wavelength of absorption also implies that there is a decrease in the amount of energy needed for that particular absorption, because from lessons before this one we have said that energy is inversely proportional to the wavelength, which means that as wavelength increases, energy decreases. So the next one, isochromic shift. Isochromic shift is like the opposite of the bathochromic shift. So isochromic shift occurs when there is a decrease in wavelength of absorption, which can also occur due to several reasons. And like I said, if there is a decrease in wavelength, that implies that the energy of absorption has also increased. So this is when there is decrease in wavelength of absorption. Now, the last two terms I'll be talking about is the hyperchromic effect and hypochromic effect. These two terms has to do with intensity. So, like I said, bathochromic shift and the isochromic shift, the two of them has to do with wavelength. But the last two terms we are now going to be considering has to do with intensity. So, an effect that brings about an increase in intensity is called the hyperchromic shift effect, while an effect that brings about decrease in intensity is the hypochromic effect. This occurs when there is increase in intensity. This occurs when there is decrease in intensity. So these are the terms that we have to take with, and we are going to be needing them in subsequent lessons that we are going to consider. Before I leave this aspect of terms that we use in UV spectroscopy and go to Woodward Fieser's rules, there is also something that we also have to take with, which we call the solvent effect. Solvent effect. Now, this implies that the maximum wavelength of absorption for a particular UV spectroscopy can always be affected by solvent that is being used for that particular UV spectroscopy. So, and the impact of solvent can result on the molecule or the compound that is being examined, can result in a bathochromic shift, that is an increase in the absorption wavelength, or an isochromic shift, which implies a decrease in the absorption wavelength. So we also have to know that the impact of solvent on various kind of compound that is being examined in UV spectroscopy also differ. For example, when we are looking at conjugated dienes, that is compounds that have conjugated double bonds, the impact of change of the solvent is not really significant as compared to when you are looking at unsaturated carbonyl compounds, because these are the major two classes of compound that we're going to be looking at in UV spectroscopy, and I'm going to talk much about that in the subsequent videos. So I want us to know that the impact of solvent, these two classes of compounds I've mentioned, differs for conjugated diene compounds, the impact of solvent change is not much, does not have much significance as compared to when you have a unsaturated carbonyl compound. And that implies that if probably in a question they give us a conjugated diene compound, you might not really consider the solvent effect, because the effect of solvent on conjugated diene compound is not more significant. But when you are giving an unsaturated carbonyl compound, you have to consider the kind of solvent that is being used, because that could either lead to a bathochromic shift or an isochromic shift, which implies an increase in the maximum wavelength of absorption, or a decrease in the maximum wavelength of absorption. And generally, polar protic solvent also tends to stabilize some of the molecular orbitals that we have talked about, which includes the pi bonding orbital, the pi antibonding orbital, and the non-bonding molecular orbital. These three orbitals becomes more stabilized when you use a polar protic solvent, and that's the reason for the solvent effect. So that also is very important for us to know that solvents used in UV spectroscopy can influence the maximum wavelength of absorption, either to bring about a blue shift or a red shift, which usually occurs in unsaturated carbonyl compound, but is less significant in conjugated diene compound. So we must take note of that. Now, the last thing I want to talk about in this video is to introduce us to Woodward Fieser's rule. Woodward Fieser's rule is a set of rules that helps us to calculate the maximum absorption wavelength for any compound given to us. But majorly, like I said earlier, in this particular lesson, we are going to be looking majorly on conjugated diene compounds and unsaturated carbonyl compound. And we are going to be applying the Woodward Fieser's rule. We are going to be using it in calculating the maximum absorption wavelength of these various compounds. And generally, by Woodward Fieser's rule, the maximum absorption wavelength of any compound is always equals to the base value of the chromophore in the compound plus summation. This symbol implies summation of all of the lambda value, summation of all lambda values of the oxychromes or substituents in the compound. So from the Woodward Fieser's rule, we can say that the maximum absorption wavelength of any compound can be gotten by adding the base value of the chromophore, which implies that when you have a compound, you have to identify the chromophore in the compound. So for different chromophore in a particular compound, there is a base value for them. So the base value of the chromophore plus the sum of all the lambda value of any oxychrome or substituents that are present in the compound. But in calculating the maximum absorption wavelength of any compound, we only consider substituents, or let me say oxychromes, that are directly attached to the chromophore. So it implies that if you have a substance that is not directly attached to the chromophore, you might not need to use it in calculating your maximum absorption wavelength. I'm going to talk much better on this maximum absorption wavelength in the subsequent video. But basically, like I said, Woodward's rule is a set of rules that can be used to calculate the maximum absorption wavelength of any compound. And this is the formula that we are going to be using in calculating the maximum absorption wavelength for compound. And like I said earlier, for this particular series, we are going to be looking majorly at conjugated diene compound, that is compounds with conjugated double bonds. At the same time, we're also going to be looking at unsaturated carbonyl compound, and we're going to be applying the Woodward Fieser rule in calculating their maximum absorption wavelength. So, in summary, what we have discussed in this video is to introduce us to several terms that are used in UV spectroscopy, at the same time to give us a brief introduction into Woodward Fieser rule, which is used in calculating the maximum absorption wavelength of compounds in UV spectroscopy. So in the next video, I'm going to be talking much better on Woodward Fieser rule as it applies to conjugated diene compound and also as it applies to unsaturated carbonyl compound. So thank you for watching another section of lessons about UV spectroscopy. I hope that you continue to watch, you also continue to like, and also share with friends that you know can also be in need of this video. And if you have any questions or comments, you can do well to drop your questions and your comments in the comment section. I will be happy to receive your response about my videos and also your questions about the video. Thank you for